So as you recall, our initial results for movies similar to Star Wars using item-based collaborative filtering techniques didn't come out so well. So let's figure out why and see what we can do about it. So let's figure out what went wrong with our movie similarities there. We went through all this exciting work to very easily with pandas compute correlation scores between movies based on their user ratings vectors. And the results we got kind of sucked. So just to remind you, we looked for movies that are similar to Star Wars using that technique, and we ended up with a bunch of weird recommendations at the top that had a perfect correlation. And most of them are very obscure movies. So what do you think might be going on there? Well, one thing that might make sense is, let's say we have a lot of people who watch Star Wars and some other obscure film. We end up with a good correlation between these two movies because they're tied together by Star Wars. But at the end of the day, do we really want to base our recommendations on the behavior of, one or two people that watch some obscure movie? Probably not. I mean, yes, the two people in the world or whatever it is that watch the movie full speed and both liked it in addition to Star Wars, maybe that is a good recommendation for them, but it's probably not a good recommendation for the rest of the world. We need to have some sort of confidence level in our similarities by enforcing some minimum bound of how many people watched a given movie. We can't make a judgment that a given movie is good just based on the behavior of one or two people. So let's try to put that insight into action here. So what we're going to do is take a look, try to identify the movies that weren't actually rated by very many people, and let's just throw them out, okay, and see what we get. So to do that, we're going to take our original ratings data frame and we're going to say group by title. Again, Pandas has all sorts of magic in it, and this will basically construct a new data frame that aggregates together all of the rows for a given title into one row. And we can say that we want to aggregate specifically on the rating, and we want to show both the size, the number of ratings for each movie, and the mean average score, the mean rating for that movie. So when we do that, we end up with something like this. So this is telling us, for example, for the movie 101 Dalmatians, 109 people rated that movie and their average rating was 2.9 stars. So not that great of a score, really. So, this, if we just eyeball this data, we can say, okay, well, movies that I consider obscure, like 187, had 41 ratings, but 101 Dalmatians, I've heard of that. 12 Angry Men, I've heard of that. Seems like there's sort of a natural cutoff value at around 100 ratings where maybe that's the magic value where things start to make sense. So let's go ahead and get rid of movies rated by fewer than 100 people. And yes, I'm kind of doing this intuitively at this point. Like we'll talk about later, there are more principled ways of doing this where you could actually experiment and do trained test experiments on different threshold values to find the one that actually performs the best. But initially, let's just use our common sense and filter out movies that were rated by fewer than 100 people. Again, Pandas makes that really easy to do. So we can just say popular movies, a new data frame, is going to be constructed by looking at movie stats, and we're going to only take rows where the rating size is greater than or equal to 100. And I'm then going to sort that by mean rating, just for fun, to see the top rated, widely watched movies. I'm getting this warning now. Ever since I originally created this course, a new version of Pandas came in. You can just use sort underscore values there, and it will work just as well. Make that warning go away. And we end up with this. So, we have basically here a list of movies that were rated by more than 100 people, sorted by their average rating score. And this in itself is a recommender system. Highly rated popular movies. A Close Shave apparently was a really good movie, and a lot of people watched it and they really liked it. So again, this is a very old data set from the late 90s. So even though you might not be familiar with the film A Close Shave, it might be worth going back and rediscovering. Add it to your Netflix queue or whatever. Schindler's List, not a big surprise there. That comes up on the top of most top movies lists. The Wrong Trousers, another example of an obscure film that apparently was really good, and it was also pretty popular. So some interesting discoveries there already, just by doing that. So things look a little bit better now. So let's go ahead and basically make our new data frame of Star Wars recommendations, movies similar to Star Wars, where we only base it on movies that appear in this new data frame. So we're going to use the join operation to go ahead and join our original similar movies data frame to this new data frame of only movies that have greater than 100 ratings. Okay, so we're going to create a new data frame based on similar movies where we extract the similarity column, join that with our movie stats data frame, which is our popular movies data frame, and we'll look at the combined results. And there we go. So now we have restricted only to movies that were rated by more than 100 people, the similarity score to Star Wars. So now all we need to do is sort that. Better get that warning again. Yeah, let's use sort values instead of sort. Reverse sorted, and we're just going to take a look at the first 15 results. And hey, this is starting to look a little bit better. So Star Wars comes out on top because it's similar to itself. Empire Strikes Back is number 2. Return of the Jedi is number 3. Raiders of the Lost Ark, number 4. You know, it's still not perfect, but these make a lot more sense, right? So you would expect the 3 Star Wars films from the original trilogy to be similar to each other. This data goes back to before the next 3 films. And Raiders of the Lost Ark, also a very similar movie to Star Wars in style, comes out as number 4. So I'm starting to feel a little bit better about these results. There's still room for improvement, but hey, we got some results that make sense. Woohoo! Now ideally, we'd also filter out Star Wars. You don't want to be looking at similarities to the movie itself that you started from, but worry about that later. So if you want to play with this a little bit more, like I said, 100 was sort of an arbitrary cutoff for the minimum number of ratings. If you do want to experiment with different cutoff values, I encourage you to go back and do so. See what that does to the results. You know, you can see here that the results that we really like actually had much more than 100 ratings in common. So we end up with Austin Powers coming in there pretty high with only 130 ratings, so maybe 100 isn't high enough. Pinocchio snuck in at 101, not very similar to Star Wars, so you might want to consider an even higher threshold there and see what it does. So keep in mind too, this is a very small, limited data set that we use for experimentation purposes, and it's based on very old data, so you're only going to see older movies. So, you know, interpreting these results intuitively might be a little bit challenging as a result, but not bad results. So let's move on and actually do full-blown item-based collaborative filtering where we recommend movies to people using a more complete system. We'll do that next. So that's looking much better. You always need to watch out for spurious relationships. So there's a certain amount of confidence or support that you should have when you're looking at relationships and data. And by enforcing that minimum threshold of support, we've ended up with much better and more reasonable results. So good lesson to learn there. Let's take it to the next level and actually do full-blown item-based collaborative filtering and produce recommendations for an entire user based on their entire history. And we can build a system that can do that for any user in our data set. We'll do that next.